This is section 5.8, Transcendental Functions. In this video, we're going to go through number 21 in your book, asking us to take the integral of this function. Looks like tons of fun. Okay, so this section's a little crazy. We learn a bunch of new integration formulas, but basic game plan for most of the questions in this section is we're going to take whatever formula they get, or whatever function they gave us, and try to get it to match one of the formulas we learned in this section. Okay, so looking at what I have now, I don't know how to take the integral of it as it is. I'm going to try to make it match one of these. Well, which one does it most closely resemble? I see that there's a radical, so it's probably either inverse sine or inverse secant. And between these two, I see that the function that I have more closely resembles this formula here. I have some variable on the outside, and also it's written as variable to some exponent minus 1, whereas inverse sine is 1 minus x squared. Okay, so by that reasoning, I'm probably going to try to get this function to match this thing right here so that I know what the integral of this is. It's just inverse secant. Okay, but this doesn't match this formula exactly as it is, so I'll need to rewrite it a little bit. My formula tells me that inside the radical, it's x squared minus 1. I have x to the fourth, but I could rewrite this as dx over x radical x to the fourth. I could write that as x squared squared. Because remember, exponent rules tell me to multiply these two things so that it would become x to the fourth. So I could rewrite it as x squared squared minus 1. And you might see where this is going. I can use my good friend u-substitution, and I can set this x squared equal to u. So that when I plug it back in, it matches my formula exactly. I'll have variable squared minus 1. All right, remember for u-sub, set some function equal to u. Take the derivative of both sides. On the left side, I get 2x dx is equal to du. Solving for dx, I get that dx is equal to du over 2x. Now I'm just going to plug my dx in for my dx here, and also plug my x squared in for u. So plugging all that in, this becomes 1 over x radical u squared minus 1 times my dx became du over 2x. Okay, generally what happens with u-sub is that things cancel. In this case, though, they don't cancel. So I'm going to go ahead and multiply things out and see what happens. When I multiply this 2x with this x that's out here, it becomes the integral of, write my du up here, du over 2x squared radical u squared minus 1. Okay, it looks like I'm written in terms of two variables, but remember, my x squared equals u. So I can rewrite this again, and it becomes integral of du over 2u radical u squared minus 1. And what I have here matches my formula exactly. I have u radical u squared minus 1 matches this formula. That means I can just say that this integral is equal to inverse secant. So taking this integral, I have, remember I still have this 1/2 out here. I have 1/2 inverse secant of my variable is u. And remember, it's an indefinite integral, so I add a plus c. And that's about it. But remember, I want my answer in terms of the variable that they started with. So I'm going to sub in my x squared for u. So now this becomes 1/2 inverse secant of x squared plus c. And that's it for this problem. These problems have a lot of steps in them, but basic general idea of how you want to approach these problems is look at what you're given and try to get it to match one of these formulas. A lot of times I'll have to use u-sub or rewrite the function in a different way, but once you do, you're able to just plug in one of the formulas that they gave you and get your answer. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in, but all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.